So I'm Ajinkya and this is Guru. We're the managers of the Maths and Physics Club. It's a club that comes under the Institute Technical Council. The idea of this presentation and this interaction today is to give you an idea of how science and maths and physics in particular is dealt with in the student community. What we'll be going through here is, first of all, we'll talk about our club, the vision that we share, and then we will talk about why do we need a club like this. Not because there are a lot of student activities that happen. The part that makes Maths and Physics Club special is that it's the student faculty coordination is much better, and there are a lot of activities that we have which not only highlight what we learn in the classrooms, but are also in a lot of sense an extension of what we learn. And this is especially true in the case of maths. So then we will talk about what the activities are. So Guru will talk about two activities in particular: the group discussions that we conduct and a summer-long event called the Summer of Science. We'll also talk about the working of the club, especially the hierarchy and the distribution, so that is especially useful in making the whole activity feasible. The last part of the presentation would be on the importance of doing the right things. So it's very important to realize that the reason the club has an 8+ years of history. The reason the club has gone so far is by doing a lot of right things, which is where I'll also highlight the importance of faculty-student coordination. So first of all, Maths and Physics Club was started as the primary source of meeting place for people who are interested in basic sciences from the perspective of knowledge, and only for learning more about these subjects. So around 8 years ago, when the seniors who started the club came together, they realized that there are a lot of enthusiastic students amongst us who are genuinely interested in talking, who are conducting discussions, solving Olympiad questions, or just discussing maths in general without having any burden of academics on them. And for this reason, the club was set up and slowly it was instated into the Institute Technical Council. The idea is that we act as a community which brings about like-minded people, both amongst students, professors, and even among students. There's a huge variety that we have in IIT Bombay. So there are undergraduates, there are postgraduates, there are PhD students, and all of them we have a good representation of all of them who come together to discuss whatever they like. The idea of why we exist is that the club, people in any campus, in any college in India, especially in technical colleges, lie on a wide range of spectrum. So there are people who want to devote their entire life to maths and physics. There are people who are just slightly interested, and there are people who are not at all interested. So all these people have different demands from a community like us. There are people who would like to participate in a one-day quiz, but keep it to that, not extend it further. There are people who would love to have events which go stretch for days and days, and there are people who would seize every opportunity to come and visit us. So that's the primary reason why we exist. Of course, like I said, there is a lot of variety amongst the students, and therefore the taste point. Finally, any discussion that happens, say 10 people come together and talk, that's not necessary that it would be a very good discussion. The guarantee that a group discussion will be fruitful, the guarantee that there will be people who are there to guide the discussion, the guarantee that if you're conducting a competition, the quality will be good. All these come from the fact that we are an institute recognized body. The GSTA takes care of the fact that all our activities happen well and they are coordinated well. There are faculty in charges of the clubs who looks after the activities. So all this institute backing also it plays a major role in making sure that we are able to scale ourselves. And provide better quality as much as possible. So now we'll talk about the events in particular. So Guru will talk about them.
So hi guys, I'm Guru. So what do we do? The activities that we do, they didn't come out in a single year. It's the composition of many years of feedback, like what are the current tastes and what people are interested in now. So the best events that I think are group discussions because they actually build the community. Like there are actually a group of people who are not really interested in hand-wavy explanations. They are interested in understanding things in a deeper way. They're interested in making things intuitive rather than algebraic or geometric. So they can, I guess, there is a need that engineers don't get detached from basic sciences. There is an element of basic science that gets applied in every engineering perspective. And although it's good to know the calculations on the engineering domain of that, but a knowledge of the basic principles might actually supplement that learning. So let's go to our first event, group discussions. Basically, we had people asking us why, so I can give you the example of a recent group discussion. The recent group discussion was on music and maths. So the question was, you have tunes, right? Indian tunes, rag. Why do some tunes sound very pleasant and other are a mere cacophony? So the answer comes from a totally unrelated area. It's called measure theory in maths. So how do these things that are completely detached, they get attached? What is the connection between them? So, okay, maybe if a person wants to know, he can just Google it up, right? Why does he need MNP? Basically, when you go to Google and search for sites like Stack Exchange or other things, they require like TERS theorems. They explain it, this is a consequence of that theorem. You can prove it, it's trivial to prove. So we bring together a community of people who actually know maths and who are interested in physics. In that GD for particular, we actually brought in a keyboard. We had people from the music club. We have PGs, UGs, and there were discussions like why this rag is sounding as beautiful and that rag doesn't. So I guess on a deeper level, we do not encourage, we do not teach them. We encourage them to pursue something on their own. Like I got so excited from that GD that I'm currently taking a course on measure theory. I'm actually seeing stuff that I discuss in those GDs. Other than that, like there are also quite like abstract maths or modern maths. It's quite unintuitive. Like for an example, there's this paradox. It's called Banach-Tarski paradox. It's very simple. You take an apple. You can make, I think, 7 cuts. You have slices of apple. If you join those slices, some theorems in math will tell you will get 2 identical apples. Not less in density, same in density as the previous one, right? Or there is a sum of numbers, like 1 plus 2 plus 3 plus 4 till infinity. The sum should be positive, right? But it comes as minus 1 by 12, right? So these things, I mean, pursuing it on our own require like years of hard work. You have to take certain courses to understand what actually goes on. In our GDs, we try to like develop an intuitive way of understanding why this occurs. The way our GD happens is we pick up a problem and then there's a person who guides the GD. So he doesn't just come about and say, okay, this is the problem and this is the solution. He tries to hint them, like give them hints, think in this direction, why not think in that direction? We argue, we debate, we hypothesize. Sometimes we experiment. We actually have our own experimental lab, you can say. And we actually use them to like test hypothesis on spot. So I feel this is the primary reason why this community is thriving right now. There are a group of people who are actually interested in breaking down complex math into intuitive things. So why GDs? I think I have explained it. So these are the pictures from our GD. We have people, like the number of people that come in are from 20 to 40 and sometimes even 40 plus. Although it's tough to handle 40 plus people, it becomes a Lok Sabha debate. But it's fine. As long as people are interested, we are fine. So Summer of Science. Summer of Science is a novel initiative. Like it truly justifies the meaning of learning. So what we do in Summer of Science is, suppose, say, you want to learn measure theory, or suppose you want to learn control systems, or probability, or abstract algebra, but you don't really know where to start from. if you take a book from the market, it assumes a set of prerequisites, right? That's a departure from class 12. So in 11th and 12th, you don't really need any prerequisites to read any book. You just go by the lemma that if you are in class 9th, you can read class 7, 6 books. But here, in actually undergrad math and physics, so what happens is, if you pick up a book, it starts with, okay, there is this lemma, it needs to be proved. You can find the proof of this lemma in another book. And again, if you take that book, you again go back to another book. So you just keep going back. So we found out a solution. We said, okay, there are people who have taken courses on control systems. There are people who have taken courses on abstract algebra. Why not ask them? Ask them, okay, you can guide me on how to go from here to here. Suppose I want to learn this topic. You guide me, you say, okay, learn these chapters from this book, learn these chapters from that book, watch this video lectures, you can refer to this notes, or maybe you need these things, and maybe you can clarify my doubts too, right? So in Summer of Science, what we do is, we have a group of mentors in different topics, and the topics range from control systems, probability theory, measure theory, abstract algebra, chemical kinetics, biochemistry, biophysics, and also finance and other like stock market analysis. So we have mentors from these areas. They guide mentees to reach a certain goal. So at the end of summers, mentees learn these subjects throughout summers, and at the end of the summers, they have to submit a report. Now, why SOS? As in, one point is, there is someone to guide you, right? There is someone to handle each step of yours. They can suggest you, okay, maybe if you are having problems with this approach, try that approach. Otherwise, I feel there is a large group of students who actually feel the lectures are quite fast-paced. They feel in lectures we use some theorems or some results that are quite non-intuitive. And they don't really have that kind of closure with the topic. They feel, okay, I know this, but hand waviness. I'm not quite deep with that topic. So that's the best way, like spend your summers, go to the extent of your learning, like whenever you feel, okay, I have done enough work, just submit the report. So that's like truly enhances learning in its like pure form. So initially we had only 50 mentees. Now we have over 400 mentees. We have mentees registering from other colleges. And you would be glad to know that last night, some guy from St. Stephen's College, Delhi, he wants to do Summer of Science in his college, and he was asking for our inputs. And as of now, 3 colleges have asked us for our inputs. So I feel this really signifies that there is a large group of people who are quite interested in basic sciences. They just need to be guided. And once they take up these projects, they have actually gone on to pursue interns and actually have made careers out of it. I have known seniors who have taken topics such as quantum computation and are actually planning their PhD in it. So this is a novel initiative. It has the power to actually make people change their like majors also. We have people changing from electrical engineering to aspects of electrical engineering in particle physics. So that's a novel initiative. Yeah, so as of reports, they are quite a good reports. They are not just typecasted from Wikipedia or something. Like if you look at the first report, it's from my friend Abhishek. So what Abhishek tried to do in his SOS, see in first year we have a course on quantum mechanics, and quantum mechanics is as it is, it's quite weird. So people don't really have a notion of why the particle doesn't exist here, why the uncertainty principle. So what Abhishek was quite troubled with this problem. So what he did was, he took something that he understood very well, classical mechanics. And he tried to get a connection between classical mechanics and quantum mechanics. And he actually achieved a sort of connections. There are equations that quite look similar in both the formalisms. So in SOS, it's not just like random reading, you can solve problems too. And that's research, right? That's research in its true form. You just strive on and until you get success, right? Others are SOS reports on machine learning and abstract algebra. So enough learning. Now to stimulate the gray cells, we have competitive events. So the idea to make events is to offer what people want. Like if you're opening a restaurant, you will only serve things that people want to eat, right? So we have something for everyone on the spectrum. So there are people who don't like maths and physics, but they're quite interested in logic problems, right? They solve those riddles and Sudoku. For them, we have logic GC. And there are people who are actually interested in experimental physics. They don't like theory. They try to tinker out and test things in the hardcore, like on board. For them, we have physics detective and physics GC. And there are again the canonical people like us who are interested in solving problems. And for them, we have Bazinga, physics and maths. And actually, there's Mathathon too. Mathathon is for people who like Olympiad problems. So Olympiad problems are quite different from normal math problems. In normal maths problems, it's like solve for X. But in Olympiad problems, can you achieve this? Can you find out an algorithm that will transform this into this? I think like teachers should actually give Olympiad problems as problems of the year. They should give it so that students can solve it and submit them at the end of the year. It's actually a good way. Like the drastic difference between pre-undergrad maths and undergrad maths is, pre-undergrad maths is a set of principles to calculate something. But undergrad maths is a set of ideas. There are different ideas. I mean, there are ideas from differential equations that map to ideas in geometry. You will be surprised to find equations. There are equations that depend on how something looks locally, but if you actually solve them, they will depend on how that whole space looks globally. So this local to global correspondence, like modern maths is quite interactive. So this idea of changing things from calculating X or solving integrals to actually pursuing ideas, that's the difference between them. So we try to come in that front. We try to encourage people to pursue things on their own. These are some of the photos that I found from our events. This is Bazinga in progress. There are people currently solving question papers, and those are the winners. And yeah, those are the people in teams, like having fun. Other than that, if you look at that photo, that is Professor Kundu from physics department, and he's judging a Van de Graaff generator. So that generator has the power to stimulate voltages in excess of 1000 volts. And those are prepared from household items. So we encourage people to make experiments ranging from things that they can generally find out in their hostel. It also promotes hostel culture. You have people from electrical, mechanical, people in physics, all of them collaborating and making something new, right? So that's where I think Maths and Physics Club plays a great role. Other than that, yeah, so I think every community needs to be educated so that it can develop and become more than themselves. So we have talks, we also visit lab, and actually Maths and Physics is quite broad. It has things from economics to biology to chemistry. So our talks are also varied. They're not like lectures. There are talks on quantum biology, there are talks on information, there are talks on astronomy, right in progress. There's Professor Varun Bharerao giving a talk on astronomy. And we do visit labs. So superconductivity is quite posh right now. It's the hot area of research. So that's us visiting superconductivity lab at TIFR. So yeah, so I think coming to the talks too, people get interested in them. They get an overview of what the subject entails. That's good for making them encourage to take courses in that areas too. So enough about what we do. So how we do it. So there are 3 components to our club. There are managers, me and Ajinkya. There are conveners, our friends who help us actually manage stuff. And there are enthusiasts. So conveners, we represent the club officially. Conveners, we have 5 conveners. There are people currently in their sophomore year. They're going to their second year. And they actually ideate events. We just guide them on the right path. Because as of again, if you have an event and people fail to show up, then you're definitely doing something wrong. So with our experience, we just guide conveners to propose new events. And enthusiasts, basically there are people who are really interested with our club, who want to be associated with our club, but maybe not organize events, or sometimes organize events at certain points. So they are people who come forward to help the club out of their own accord. So it's imperative that we take them under our wing, right? Uh, so our work entails, like most of our work is done in summers. In summers, we prepare questions, we discuss what to do next sem, which professors to invite, which labs to visit, and other things too, like we fix dates for what to do. So what do we have? So as every community needs a place to hang out, a place to read, a library. So we have library. Basically, our library has all non-technical books. Like there are comics on relativity. There are comics on quantum physics. There are just memoirs of great mathematicians, men of mathematics. So I feel if we have great people to look up to, we'll really push our boundaries to actually achieve that kind of greatness. Otherwise, like since summers, we don't really meet during summers, people are away. So social media is a good way to interact. We post videos. Like recently we had Feynman's birthday, so we post a video of him. And generally, even if we find something interesting, we just share it with everyone on social media. Okay, so how do we plan an event? So for planning an event, conveners actually take up the ground level execution. They handle the event. They are on the stage while the event is progressing. And the planning out, booking the room and fixing the dates, they're pretty trivial stuff that we do during summers. And yeah, we do it well in advance, so not to avoid clashes with other clubs too. Yeah, so that's our inventory. That's the book I was talking about, Men of Mathematics. And this is our experimental lab, quite a humble experimental lab. We have actually made Tesla coil. I think it's fair to, I have sufficiently and necessarily satisfied all of you that we exist and we do something. Now, why do we do something? Like, again, it's a fair question to ask. Why does this club work? Like, we have online presence of over 8,000 people. Like, there's an article that we shared on 100 years of quantum theory. We found that it was reshared by a German professor. So you can be quite sure that our reaches are quite far. And yeah, so the main question to ask is, why does something like this work? Why doesn't this fall apart? Why are there different iterations of this thing? So I think Ajinkya can highlight you on that.
So the idea behind having these last few slides is that the club exists, fine. These are the activities that we do, great. But these slides cannot necessarily replicate the last 8 years that have gone into getting where we are. So what we wanted to do is we wanted to highlight the points that are that we think are most important and are the reason we are able to stand where we are today. So the first point is that there is an extensive and regular planning that goes into the work. So for example, if you want to set up something like this club in your colleges, the first problem that we have faced, so like Guru mentioned, there are colleges that have come to us. So the biggest problems that we have seen coming across in different places is the lack of planning and a lot of withdrawal. So people are not really sure if they have the resources or not. So the first and most important thing is that having regular planning. So it starts with forming your motivation. What is your vision for the club? So we are the managers for this year. We've had 8 different sets of managers over there. Everyone has had their own vision. So these visions and how you take them forward are very important, because unless our vision is clear, the conveners do not have a clear direction to go to, and the club doesn't progress. The other thing is that there are a lot of things that happen throughout the year. So, for example, there are 1,000 other clubs in the institute. There are holidays, there are exams, there are vacations. So, a lot of these things have to be taken care of, and these planning have to be done very rigidly. So, for example, we are currently in the progress of planning for the next whole year. So, that's around 9 months of planning. So, that's something that needs to be taken care of. The one important thing that needs to be highlighted is that it might seem like a lot of work, because there are so many activities that happen throughout the year. If you start listing them down, they do look like something gigantic. But it's an year-long thing. So the average workload that we have found, it comes down to is around 2 hours per week, which I think is very fair, because the amount of output that you get from it is momentous. So the other thing is that in today we need to maintain an active community for almost anything. Given a college like IIT Bombay, we have a student community of over 10,000 people. In such a scenario, the need to make sure that we reach out to every student who is interested can only be fulfilled through an active community. Here, one point that's not mentioned that I would like to highlight is again the backing of faculties and the institute, which is the reason why we can post our events on, say, the institute mailing address GPO, and post and say put up posters around the institute. All this, so the money for these posters, everything comes from the institute. So this is one of the reasons why we are able to maintain an active community. We need to find a source, as I said, we need to find a source of motivation. At the same time, documentation and stuff like making sure that the past year doesn't get erased in the next year is very important. So for example, Bazinga Maths and Physics came up around 5 years ago. At that time, it used to be held in these LH venues. Now it has gone up to that we need to conduct it in LS. Logic GC has been going on for around 8 years now. But at the same time, there are events like Mathathon, which was started just last year. But to make sure that all these events are well aware is why we need to make sure that all the documentation is complete, so that we can make use of what has happened in the past. Another major thing is that all the work that we do is volunteer. Academics, sadly, is not volunteer. A lot of stuff that we learn is not. We do not. A lot of things that we learn are what we need to learn. But the fact that every person in the group has come up on his own, while the position of the managers and conveners is official, but at the same time they have volunteered themselves to come and stand for these positions. So there is a guarantee that these people who are here are actually interested in the activities. They have all these applications start from after their fresh year. So they have already had an year of exposure to all these events and therefore make an informed decision. Even when they are in the progress, we make sure that they do a lot of groundwork. They talk to people, they talk to professors, they talk to senior students, and make sure that they know what they're getting into. So this voluntary nature of the activities and the whole environment that makes it positive and a break from academics is one of the major reasons why it works out. Like I said, institute backing always provides recognition. For example, one of the strongest examples of this is Summer of Science. So the first year we had 50 students. From the second year onwards, we made sure that the Dean of Student Affairs would personally certify all the certificates that we give out. So we take the responsibility of checking the reports, and this certificate coming directly from the Dean of Student Affairs gives it a different level of recognition. So people strive to get better reports, because whatever they write in the report is what is reflected in those certificates. And we take the guarantee that whatever they write in the report, from making sure that we talk to the mentor, is what they have studied. So this makes a Summer of Science itself a learning opportunity almost equivalent to doing a course. And because it's self-paced and self-planned, it makes it even more interesting. Most importantly, and very simply, because every activity that we have is made with the desire of keeping it fun. So we don't have the same set of 10-15 people who come to every event, but there are always 10 to 15 people coming to every event, and that's the difference. Because there are always people who will be interested in the basic sciences, who will be interested in pure maths, who will be interested in physics. So a lot of us are not interested in the equations that got us to a lot of interesting physics phenomenon, but what is the phenomenon exactly? A lot of intuition is often drowned in a lot of maths, and that's not what even I as a physics student look at. So all these things, so we try to make sure that what we do is fun. So to give you a last example, Mathathon was purely started because people complained that the older events were time bound, and Olympiad questions should not be time bound. They should be having their own enjoyment. So we started Mathathon last year which was a day-long event. So it started in the morning, and people could solve questions for as long as they want and take as much as they want. And if they solve them fast, they can go to the next question. So we had people who ended up staying for around 15 hours. And at the end of the day, we had to close it because the room booking was over. This was the only reason we had to stop at that day. So yeah, I think that's it. So we would really like if you take home the message that a community is built from students and people who are actually interested in what is needed. So not only do we, as student representatives of the institute, we believe, and we have, as we've seen in the institute, any activity that has been taken up by students, and so the way it goes about is this. There are activities that a blockchain community has just come up in the institute. So it is one of my friends, Tezan, who started it. So what he did is he realized that we don't have a community like this. He talked to his seniors, and then they went and talked to some professors in this computer science department. And then together they have now set up a blockchain at IIT community. And that community is ever growing. So there's already 100+ people who are actively participating in their activities. So these communities are not difficult to form or not difficult to maintain. It's just some regular decent effort from people who are interested, and that can drive home the message. Thank you. So there are a lot of roles of the faculty. So first of all, we have a faculty in charge of the club. So Professor Pant from Mechanical Engineering, he looks after the activities of the club. So we consult him regularly. That's one aspect. The other aspects are that, so we have professors who come for lectures, who come to give these talks, who come and visit talks. For example, Bazinga is judged by professors. You saw Professor Kundu who was judging physics GC. So the Van de Graaff generator that was made was for physics GC. So they participate in that way. They also participate in, so we regularly try to call them for group discussions and other events. So that's another aspect. The other is that whatever activities that we plan, we make sure we go to profs and talk to them about it. So for example, the problem statements for physics, we go and talk to experimentalists in the physics department. Our question papers for all the competitive events, they go through proper faculty evaluations. So we make sure that whoever is judging the Bazinga, physics Bazinga or maths Bazinga, the question papers go through them and they make sure that the quality is maintained. So the thing is, so like I said, the calendar, like right now itself, we are in the progress of making the calendar. So we have a rough idea of when the midsems and the endsems are. And then quizzes are roughly placed between, almost midway between the midsems. There will always be the problem that kisi na kisi ki quiz aayegi. I agree with that. But at the same time, we look at our target audience. So for example, Bazinga is targeted towards the freshmen to make sure that they realize about our presence and how fun maths and physics can be. So we make sure that it doesn't clash with their quizzes. So even if it does clash with, say, some third year or fourth year quiz, because there are a lot of different quizzes going on. If they do clash, then we can't help it. But we try as far as possible to make sure. There is also the chance that it could clash with other activities of other clubs, which is why there is an institute-wide calendar that is maintained, where we all the clubs and all the other activities that happen, they are all mentioned, so that clashes can be avoided.
Let's take 3 points, 3 random points, right? And let us suppose a hypothetical dice, right? So I take, let us say, another point C, and I roll my dice. So if 1 appears, suppose these are point A, B, and D, and let us enumerate them: 1, 2, 3, 4, 5, 6. Right? So what I will do is, I have taken my choice point C. I will roll my dice. If 1 appears, I will join this line, and in the middle of this line, because 1 is associated to A, I will join A to C, and in the middle of this line, I will take my new point. So this is my new point C prime. This is my new choice point. Right? Now again roll my dice. It comes 3. So in 3, I will join this line and take my new choice point here. Right? Now suppose we start with any point here and we see where these choice points go. So do you think there will be a pattern in which these choice points are distributed? Come on, the stakes are high, you should predict. Success or failure, first predict. There should be a pattern. Why? Just to clarify, just shade like a rough diagram of how the points distribution would look. So there is C0, C1, C2, right? So there will be C3, C4, C5. So I have taken 3 random points, A, B, and C. What I did was, initially I took a choice point somewhere in here. And I had an imaginary dice. I rolled it. So if 1 appears, I have my initial choice point. I have A. I take a point between them, like exactly in the midpoint. That becomes my new choice point. Now I'll again roll my dice. So if 6 appears, so then it's enumerated to D. So new choice point and D, I take a point right in between them. So I'm asking you, how would this distribution of points look? Like you have C0, C1, C2. Yeah. Circle.
Rotate the dice, then it become 1 and 2, then it goes from this to this, and center point is this. Then suppose you again rotate the dice, then suppose a random axis is 3 and 4. Then we move from this, and the midpoint is this. Now again suppose 5 and 6, then random point is.
Oh, so you are saying it will just loop about. Oh.
Or suppose you again.
That's an interesting proposition. That's a solid claim.
So here we have a simulation. So it's there on our website. So what one of our enthusiasts did is that he made a simulation of this. So for example, you can run through different number of points, etc. So we'll run for 3 points, and like Guru mentioned, we'll have a fraction of 0.5. So this is what will come out to be.
Just see. In the middle there is a hollow out, right? In the 3 triangles that form, there is again a hollow out. And again, this hollowing out process will continue infinitely. And servers on the right track, it was Sierpinski's triangle. So fractals are quite interesting. And the question lays, why does Sierpinski's triangle appear in first place? I hope you will find some enthusiasm to answer this. Thank you. What actually they do that the algorithm can generate random numbers. So it is quite similar. It takes random numbers from a uniform distribution. So they try to mimic the dice. But even if you do it by hand, you can see after like 20 tries, the pattern starts to emerge. So yeah, in trueness, you cannot generate something random from computer, but it's a good representation of what can be.
So taking inspiration from what these people have been doing in collaboration with faculty, take a minute to write down on your notebook what you would do in your institution to encourage students to understand maths and get more absorbed in maths for engineering and otherwise. And then we'll have a pair and share on that.